Good day, everyone. My name is Graphics. Today, we want to solve the problem that is displayed on our screen, and it is based on partial fraction. And we're told to solve this. It says 3 plus 6x plus 4x squared minus 2x cubed, all divided by x squared into bracket x squared plus 3. Now, what you do is you're going to equate this expression to be equals to. Now, I want to consider x squared as my denominator first. So if I put x squared as my denominator, I'm now going to put the numerator as ax to the power of 1 plus bx to the power of 0. Now you'll be wondering, what is this man doing? Now, why I come to understand this, if you have a variable, let's say x, that has a power of 2, the numerator will be ax. The x close to the a will have a power of what, of 1, plus bx. The x close to b will have a power of what, of 0. Similarly, if the denominator is x cubed, the a is going to have x to the power of 2, plus the b is going to have x to the power of 1, plus the c is going to have x to the power of 0. So you're going to move the x, the degree, to what? To 0. Now, let's come back to our question. Now, if you look at this now, we have ax to the power of 1. We know any variable to the power of 1 will give you that variable. That's why we're not having the ax. So I'll leave my ax that way. Plus bx to the power of 0. Now, any variable raised to the power of 0 is going to give us what? 1. So, and 1 times z will give us what? B. So, we're going to be having ax plus b over x squared. Now, plus the next one, we are considering x squared plus 3 as our denominator. The same thing will be applied. Now, since we end at b at the first one, we're going to continue with what? With c. Now, c x plus d, just like I did the first one. So instead of me, I'll just write the cx to the power of 1 plus dx to the power of 0. So if I do the same thing, x to the power of 1 is x, plus d times s to the power of 0 is what? Is d, because s to the power of 0 is 1. So this is what we're having here. Now, you can try this on your own. What about if I have the numerator, the denominator should be x4 plus 3, or I can say x to the power of 4 alone. So let's just try x to the power of 4 plus 3. Now, what do you think their numerator will be written as? Now, you can pause the video and guess that for yourself, but this is what we're going to be having. If we have x to the power of 4, it is going to give us ax to the power of 3 plus bx to the power of 2 plus cx to the power of 1 plus dx to the power of 0. That's what we're going to be having. Now, the s to the power of 0 that is close to d, the x is 1 because n to the power of 0 is 1. So 1 times 0 will give us d. Now, the x to the power of 1 will still give us x. So x times the variable close to it gives you that variable, right? So this is what we'll be having. So anytime you have a power in the denominator that has a degree, this is how you go about it. So let's move forward to our question. Now, if I now rewrite my expression, which is 3 plus 6x plus 4x squared minus 2x cubed, all divided by x squared into bracket x squared plus 3. We're going to be having, you look for the LCM. So the LCM of what you see above you will give us still x squared and what? X squared plus 3. That's the LCM we have. Now, if you cross multiply what you have here, or you say that cross multiply what you have here, this x squared plus 3 will going up to multiply ax plus b. So we'll be having ax plus b multiplied by x squared plus 3. That is the first one. Now, the x squared will be going up to multiply cx plus d. So we'll be having x squared into bracket cx plus d. So this is what we're having here. Now, if you look at the two sides of the equation, the left and the right hand side, you realize that the denominator are the same. So they will equate each other. So when they do that, we are going to be having 3 plus 6x plus 4x squared minus 2x cubed equals to ax plus b multiplied by s squared plus 3 plus x squared into bracket cx plus d. So I will term that my equation 1. Now, if I expand the equation 1, I'm going to be having 3 from the left hand side. I'll be having 3 plus 6s plus 4s squared minus 2s cubed equals to now ax times x squared. I'm multiplying this and this, right? So ax plus s squared is going to give us ax cubed. Now I'll multiply ax times 3, I'll be having 3ax. Now I'll go to the next one. Use the b to multiply the other one. We have b times s squared will give you bs squared. B times 3 will give us 3b plus s squared times cs give you cs cubed plus s squared times d will give you dx squared. We are having this. Now you rearrange according to their degree. So if I rewrite again, I have 3 plus 6x plus 4s squared minus 2s cubed equals to, we have as cubed and cs cubed, they have the same degree. So we'll bring them together. Similarly, bs squared plus ds squared, they are the same. I'll bring them together. Plus 3x plus 3b. So this is what we're having here. Now, if I factorize each of the variable in the bracket, if I bring s cubed out from the first, I'll be having s cubed. If I write it again, I'll be having 3 plus 6s plus 4x squared minus 2s cubed equals to, so if I bring the s cubed out, I'm going to be having s cubed in bracket a plus c, because when you multiply s cubed times a, you have as cubed, and when you multiply s cubed times c, we have in cs cubed. Plus, if I bring out the s squared from bs squared plus ds squared, I'll be having s squared into bracket b plus d. So if I expand it, I'll still have what I have. Plus 3a, if I bring the x out, I'll be having just 3a, then plus 3b. Now the next thing we'll do, I told you in my previous video, which you can click in the link above to watch, I said there are two ways at which you can analyze partial fraction. One of the ways is using the assumption method, and the other way is by comparing coefficients. Now what we are doing here is we are comparing coefficients. So we want to compare coefficient now. So we are comparing the left hand side and the right hand side. Now if I consider s cubed, I have my equal sign here. So if I consider s cubed, shows that at my left hand side, the quotient of s cubed is minus 2. And at my right hand side, the quotient of s cubed is a plus c. That is equation 1. Now if I consider s squared, such that at my left hand side, the quotient of s squared is plus 4. And at my right hand side, the quotient of what? S squared is b plus d. Call it equation 2. If I consider x, at my left hand side, quotient of x is 6. At my right hand side, quotient of x is 3a. Now if I consider the constant, at my left hand side, it is what? 3. And at my right hand side is 3b. So call it equation 4. Now from equation 4, we have 3 is equal to 3b. So if you divide both sides by 3, your b will be equals to what? 1. From equation 3, if I have 6 is equals to what? 3a. So if you divide both sides by 3, I'll be having a is equals to 6 over 3, which is equals to what? 2. Now, substitute a into equation 1, and we know our equation 1 is minus 2 is equals to a plus c. So if I put my a, which is equals to 2 in the equation, I'm having minus 2 equals to 2 plus c. So if I make c the subject of the formula, c will be equals to minus 2, and that will give us what? Minus 4. Similarly, I'll substitute b into equation 2, and now our b is 1. So we say that for equation 2, 4 is equals to b plus d. So I put my b equals to 1, 4 will be equals to what? 1 plus d. And b will be equals to what? 4 minus 1. So b is equals to what? 3. So this is what we have. So I will now say that, therefore, from the expression above, we have 3 plus 6s plus 4s squared minus 2s cubed all divided by s squared into bracket s squared plus 3 is equals to a. Our a, we know a is giving us 2. So I'm going to input 2 as a. So we're having 2 plus 1 because our b is giving us 1. So 2a plus 1 all over s squared plus our c is giving us minus 4. So we have minus 4x plus our d is giving us what? 3. So plus 3 all divided by s squared plus 3. So this is our answer. So if you find this video helpful, please don't forget to click on the subscribe button. Thanks for watching.